Hey everybody, this is Larry. This is me going with Q2 of the bi-weekly contest 119. Oops, we move adjacent almost equal characters. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. This one I definitely could have done a little bit faster or typing or something like this. I don't think I did it the ideal way, so maybe over here we'll spend the time to actually do it a little bit better. So I actually just didn't want to think or prove during the contest. I actually ended up spending 3 minutes here, and some of the top competitors actually did it quicker by a lot actually. So there probably is a simpler way, and I probably could have just written it a little bit faster to be honest. But the idea here that I did is taking advantage that n is equal to 100. And so I just brute force changing all the characters. I think you don't actually need to change all the characters. I mean, that would add more complexity, but for sure you can, I think you can do greedy. Yeah, I think you could do greedy actually. Is what I. But I'll go with this one, and then we'll try to do greedy. And if I'm wrong, then just pretend I didn't say anything. And thanks for watching, though. Keep watching. But yeah, the idea that I had, and this is because I didn't want to prove during the contest, is that, and this is dynamic programming, and you'd only have two states, which is index, which is the prefix or the suffix of the word of index that we are solving, right? That's the subproblem. And last is just the previous character, right? And here index, of course, have O of n. There's exactly n of them, and last could just be one of the 26 characters. And that's pretty much all I did. I was a little bit lazy, like I said, about the greedy or proofs or anything. I just go, okay, well, we're already done. We return 0. Otherwise, this is just brute force with memorization, is that we brute force, using every one of the 26 characters. And this is only good if they're not almost equal. And if they're not almost equal, then we check if this is already the current character, then we don't do a +1. If we need to change the character, which means if it's anything else, then we do a +1 here, and then we just return the best over all the 26 characters, and that's pretty much it. And I started off dirty because that's just something that's out of the range of all the things in the beginning, so that the first character you can always change or not change the value and like it. Also, you have to always or this never kicks off. Oh wait, this always kicks off is what I mean. So so for the first character we try all 26 is what I try to do here. So the complexity is going to be index times 26, which is size of alpha, right? So O of n times alpha. Ooh, what happened here? One button. It is the number of states. So the time is going to be O of n times a, because for each of these items, for each state, we do O of a or alpha work. So this is time, and O of n times a is the space, right? So this is the dynamic programming solution. It works. I did it in 3 minutes. I really wanted to just not prove. And you can kind of do the math and know that n is only 100. So this is going to be fast enough, right? So the way that I would maybe do it now is maybe just greedy, right? So here, and the greedy idea, now that I think about it a little bit, is going to be that if you have basically if two characters next to each other, they're almost equal, then you have to change one of them. If you're going from left to right, you're always going to change the one to the right to a character that is in adjacent to the one to the left and to the right. And because you can always find a character where it is not good to the left or to the right, this will always be good. So let's try that idea. It's just that during the contest I didn't want to prove it, so that was a little bit tricky, right? So yeah, so here we start with character 1 actually. So if the ordinal value of this minus the ordinal value of I minus 1, right? If this is less than or equal to 1, then that means that we have to change, right? And then I guess the better way to write this actually. Maybe I is equal to 1 while I is less than n. And in this case, we change word of I minus 1, right? So count is equal to 0. We change, and then now so I plus 1. I mean, if it's big enough, we always just increment anyway. Otherwise, we increment by 1, but then we also increment to skip the next character, because you can just find a character that's not adjacent to the next character. So we do this, and I think that probably is good. Let's see if I am maybe hopefully right 2, 2, 3. Let's give it a submit. Yeah, so I guess that's how people did it very quickly, but I didn't want to risk it during the contest, so I did it with dynamic programming. But I did, I don't know, Leetcode leaderboard is a little bit weird, but earlier I saw a lot of people did in like a minute, right? And yeah, maybe that's the way to go, but it's just a little bit awkward for me to prove during the contest. But you can kind of see that change word to character not adjacent to words of I, or words of I plus 1 always exists, right? So we do a count plus 1, and then this one is to just regular increment, but we also do another I plus 1 to skip word I plus 1, because that already is never gonna, this will never be true for word I minus 1. So this is why it works. This is even faster, of course, but and this is O of n instead of n times a times a. But yeah, let me know what you think about this one. Let me know which way you did it. I mean, and you know, I mean, I guess if I had able to do it, like shave a minute off this, I probably could have, you know, finished maybe top 10 or something. No, Josh is just ridiculous, so maybe there's no chance of winning anyway. But yeah, that's what I have with this one. Let me know what you think, and you could watch me solve it live in the contest now. But also just bad. Not, I don't care about embarrassed if it's right. But all right, Q2, slow, but let's do it. Lowercase. Remove all adjacent almost equal. Okay. Oh, it's only 100. Can that change anything? It's a DP. Yeah, okay, I think so. Yeah, I mean, it is a little bit yucky, but it should be fine. Random. So index, so okay. 223. Okay. Remember the cache? Okay, fine. If it times out, that'll be set. Okay. It shouldn't be, but with Leetcode, I almost never know anymore. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem, this contest, this explanation, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.